To integrate sine squared x, we need to use the formula sine squared x is equal to a half 1 minus cos 2x. Now I really would just recommend learning this formula, but if you forget it, you can derive it fairly easily using the double angle formula for cos 2x. So if you start with cos 2x equals cos squared x minus sine squared x. Now this identity on the top here doesn't have cos squared x in it. So what we can do is we can replace cos squared x with 1 minus sine squared x. So then on the right hand side we've got 1 minus 2 sine squared x. And then if you rearrange that to get sine squared x the subject, you'll get that identity up there. So let's do that. Let's sub this in. And we've got limits on this one. It's a definite integral from pi over 12 up to pi over 8. Now notice that the reason why we've done this is because now we can integrate cos 2x fairly easily, but we didn't know how to integrate sine squared x. So I'm going to multiply out this bracket. In fact, I'm going to take the half outside of the integral as a factor because we've got a half times by this bracket. So then we just got to try and integrate what's inside this bracket. So integral of 1 is just x, so we're going to have a half, and then we're going to go to square brackets because now we're going to integrate. Integral of 1 is just x. The integral of cos, or minus cos, if we just think sine, cos, minus sine, minus cos, the integral of minus cos is minus sine. So we know that we're going to have a minus sine of 2x. But we've got 2x inside the bracket here, so we're going to have to divide by 2 when we integrate. And you can double check that that works, because if you differentiate this, then you will end up with minus cos of 2x. If you prefer to use a formal substitution, then on the side you could say we want to work out the integral of cos 2x. We could let u be equal to 2x, or we've got minus cos 2x actually. So I'm treating this as plus minus cos 2x. So then we're going to have the integral of minus cos u, but we need to replace dx with something to do with du, using the fact that du by dx is 2. So dx equals a half du, and that's why we had to times by a half there. So times by a half du. So we're integrating a half times by minus cos u. And if we integrate minus cos, we get minus sine. So we're going to have a minus a half sine u. And then we need to sub in the limits of pi over 8 and pi over 12. So if we sub in the top limit, I'm going to leave the half at the front. And if we sub in the top limit, we're going to have pi over 8 minus a half sine of pi over 4. And then we need to subtract what we get when we sub in the lower limit. So it's going to be pi over 12 minus a half sine of pi over 6. And remember, all of this is times by a half. So I'm going to leave the half at the front and try and simplify this. So we're going to have pi over 8 minus a half, and then sine of pi over 4 is root 2 over 2. And then minus pi over 12, and then plus, because we've got minus minus, so plus a half, and sine of pi over 6 is a half. So if we just collect together these terms with pi in, we've got pi over 24, because 1/8 minus a 12th is a 24th. And then This term here is going to be minus root 2 over 4. And this term here is plus a quarter. And then I'm going to multiply through by 2. So we're going to have pi over 48 minus root 2 over 8 and plus an eighth. And then we're going to look back at the question to try and see what form they want us to put it in. So we've got the pi over 48, and then we just need to write the other two terms as a single fraction. So let's see whether we can do that. So we've got a common denominator, so we can just write that as plus 1 minus root 2 on the numerator.